A new study suggests that the interstellar object Tri-and-Atlas is unusually massive and significantly larger than previously thought. Let's take a closer look at the new data, the emerging theory, and the path of this interstellar visitor through our solar system. How large is Tri-and-Atlas? Determining the true size of a comet can be difficult. The main challenge is separating the nucleus from the diffuse coma around it. When the comet approaches the sun, its frozen ice turns to gas, carrying streams of dust into space and forming its characteristic tail, or coma. This could make the comet significantly larger and brighter than the solid body itself. A group from Harvard led by Richard Cloete, Avi Loeb, and Peter Vereš has analyzed observations of comet Tri-and-Atlas collected from May 15 to September 23 from 227 different observatories around the world through the Minor Planet Center. They compared the actual trajectory with what we would expect if only gravity acted. As a result, they discovered a small but noticeable push, less than 15 meters a day squared. However, comets with active gas outflows usually receive a small thrust from the jets of escaping gas. In the case of Tri-and-Atlas, the measured non-gravitational acceleration was surprisingly low compared to the observed gas outflow. This indicates that the core is heavy enough to withstand the influence of these jets. Based on this, researchers estimate the mass of the comet's core to be over 33 billion tons, with a diameter of about 5 kilometers, not including the surrounding coma. This is about 3 to 5 orders of magnitude larger than previous interstellar visitors. Loeb claims that given what we expect from the available population and the abundance of heavy elements in interstellar space, we should have already seen many more modest-sized interstellar objects before encountering such a massive one. However, this did not happen, and it highlights Tri-and-Atlas as a significant anomaly. Loeb even considers a speculative alternative that the object could be of technological origin, referencing its unexpectedly large mass, alignment of its trajectory, and some supposed detections of nickel without iron as provocative clues. However, NASA scientists urge caution. The prevailing opinion remains that it is most likely a natural object. Meanwhile, some scientists are questioning not what the Tri-and-Atlas are, but what their purpose is. Astrophysicist Susanna Falsner's idea is simple, yet impressive. Tri-and-Atlas may be the seed for creating a planet, but how can a wandering stone from another star system cause the birth of an entire planet? Let's take a tour. We enter a young solar system where a new star is at the center of a great dusty ring. Here, tiny grains of stone spin like smoke, merging into pebbles. Over time, they transform into boulders, and then into planetary formations, raw material for planets. Given enough time, they become massive enough to gather even more material. At first glance, everything seems simple. But as we will see, there is a serious problem. Disks cannot exist for more than a few million years before the gas is swept away. This time frame seems too short to explain how massive planets like Jupiter and Saturn could form. Now imagine another scenario. An interstellar object enters this disk, a body already large enough to become a ready core. Instead of starting with dust particles, the disk suddenly receives a solid seed that can immediately begin attracting surrounding gas and materials. Thus, an alien traveler could accelerate the birth of a new planet. Falsner's simulations confirm this idea. She discovered that massive stars capture interstellar objects better than smaller ones, and indeed, gas giants are more often found around large stars. The correspondence between theory and observations is astonishing. If this is true, then interstellar objects like ʻOumuamua, Borisov, and Atlas are not just random visitors. They may be sparks igniting planetary systems, some of which may have become the parents of gas giants in distant systems. Others could have played a role in the early history of our own solar system. This is a bold and yet unproven idea, like interstellar objects. Interstellar objects are known for their complexity and study. They appear suddenly, move quickly, and vanish into darkness. But this time we are ahead of events, as we manage to detect the object in advance, and our technology can finally allow us to reveal its true nature, rather than just guess after its disappearance. The European Space Agency is preparing the Mars Express and ExoMars Trace Gas Orbiter spacecraft to observe 31 Atlas as it passes near Mars in October 2025. These spacecraft are aimed at capturing images and data we have never had about an interstellar object, whether from orbit around Mars or from telescopes on Earth. The coming months will provide a rare opportunity to closely track the interstellar object. Astronomers noted several key events in their calendars, milestones to watch for as this guest races through our cosmic neighborhood. October 3rd, 2025, a flyby past Mars. Directly after sunrise, a comet will pass by the red planet at a distance of only 18 million miles. From the orbits of Mavin and Tianwen-1, they will see its dusty coma begin to faintly glow pink in the Martian dawn. October 29th, 2025, perihelion. In 4 weeks, 31 Atlas spacecraft will fly behind the Sun, approaching a distance of 1.36 astronomical units, which is about 130 million miles from the photosphere. At this moment, its speed reaches a maximum of about 152,000 miles per hour. The comet will not be visible from Earth due to the Sun's glare, but spacecraft on Mars and at Lagrange Point 1 will monitor its activity as jets of vapor are expelled from the freshly heated crust. December 19th, 2025. A distance check to Earth. With its tail fully unfurled, 31 Atlas will pass by Earth at a comfortable distance of 170 million miles. Too far for the naked eye, but close enough for the James Webb Telescope and Rubin Observatory to investigate its comet for isotopic clues. March 16th, 2026. A flyby past Jupiter. Finally, the spacecraft will fly past Jupiter, 33 million miles above the clouds of the gas giant. If NASA approves a small course adjustment, the Juno spacecraft will be able to deviate to collect dust samples from a comet, giving us a unique opportunity to glimpse materials formed beyond the Sun. After this, the device will return to interstellar space, leaving behind terabytes of data and many questions. What do you think about this? Share your opinion in the comments. I would be interested to hear it.